Let's focus on polar coordinates. Polar coordinates, remember, are given in the form r theta. So we have a radius out from the pole and an angle towards which or away from which we are going. So number one is asking us to graph the point given in polar form. So this is the point. Well, we have looked at how to do that on polar graph paper, but sometimes if you're just plotting one point, you don't want to have to take up a whole polar graph. So we can sketch that out. So what we would do is we would draw the pole, and you draw the positive side of the x-axis, so the polar axis there. Then you indicate the angle that is given. Remember, I mentioned that even though it's an ordered pair and the angle comes second, we're almost always using that information first. So 7 pi over 6 is important to remember. That terminates in quadrant 3. So that's down here. We're just going to estimate it. And we're going to show that as 7 pi over 6. Then our radius is -4, so we're going to go out 4 steps from the pole, but since it's negative, we are going to go in the opposite direction from 7 pi over 6. So we will mark off 1, 2, 3, 4 and plot that point. Remember, when your radius is negative, instead of going toward your angle, you're going to go the opposite direction. So here we have plotted the point. Item number 2 says to rename the point in 3 ways. And it's very non-specific. Any 3 ways would do, but I'm going to show you how you can do a combination of positive R values and negative R values. All right? So one way that we could think about naming this 7 pi over 6, we could think of what is that same angle but going backwards. So we could do 2 pi minus 7 pi over 6. This takes us all the way back to the beginning of our semester when we were working with coterminal angles. Well, that is 5 pi over 6, but since we are going in a clockwise direction, we will say negative 5 pi over 6. So one way to name this would be -4, -5 pi over 6. All right. Now, any multiple of 2 pi added to -5 pi over 6 or to 7 pi over 6 would give you an additional way to name the point. So I just want to make sure everyone is clear on that. All right. Now the other possibility that I want to bring up is what if instead of having the negative R value, we wanted to have a positive R value? So remember, we would be going toward this place if it was a positive 4. We'd really like to know what is this angle. Well, it is pi away. The opposite direction is 180 degrees or pi away. So if I was at 7 pi over 6 and I wanted to come backwards pi, that leaves me at pi over 6. So 4 pi over 6 is another option. Yet another option is, what if we wanted to name pi over 6 with its negative equivalent, or one of its negative equivalents, coming all the way backwards? Well, let's see. We would say 2 pi minus pi over 6 is 11 pi over 6. And since we're going in a clockwise direction, that would be a negative. So positive R, because we're still going towards that place, but we came backwards to locate that angle, -11 pi over 6. And then there are infinitely many ways to continually rename this, again by adding 2 pi. All right, last, what if we want to convert the point to to rectangular form? It's currently in polar form. Well, to convert polar coordinates to rectangular coordinates, x is equal to r times the cosine of theta, and y is equal to r times the sine of theta. So x would be equal to r times the cosine of theta. Well, the cosine of 7 pi over 6 is negative square root of 3 over 2, which means x would be equal to 2 times the square root of 3. Y is r times the sine of theta. The sine of 7 pi over 6 is negative 1/2, and that means y is equal to 2. So in rectangular form, that would be 2 square root of 3, 2. Which makes sense because if you could picture an x and y axis sitting on top of this, that point is in quadrant 1, and our rectangular coordinate is also in quadrant 1.